Hello, everyone. This is everyone, or are there still people coming? Very nice. Who of you ever heard of IOTA? Lots of you. This is why you're here, I guess, because I've seen people coming out from the outside said, oh, I think this is not basic tech, this is advanced. I said, no, just come here. I think it's not that advanced. We're talking about using over-owning, how to enable renting business models using the tangle and affordable IoT hardware. So if you know what IOTA is, I think there's a slight chance that you also know what the tangle is. This is us. My name is Stefan, and this is David Lobato. David Lobato is from Faro. We both work for Turbine Kreuzberg, which obviously is a quite German company, but we also have a subsidiary in Faro. At the bottom you see some pictures of a hackathon that David and me attended in February, I guess. We didn't win anything, much worse than Musin, but we had lots of fun deploying some application with IOTA, and it was quite successful, I would say. But this is not exactly what we are talking about today. What we're doing today is we want to show you how we have invented a use case, more or less an abstract use case, with which we can enable a group of items, so-called owners, to control who is using their item, which sounds a little bit abstract. I will just give you an idea. So let's imagine that several owners agree on owning an item, whatever an item is, I will show in a minute. The owners want to share the item among each other. They are forming a so-called sharing group. To use an item, the requester who wants to use the item must post a deposit. To use an item, the user also has to pay a usage fee. I mean, this is quite obvious. If you use something, it should cost something, I would say. This is how the world is working mostly. The item can report its usage or maybe even the overusage and add that overusage to the fee. So in the end, you pay for what you use. The refunds, so to refund the deposit or the amount of money that is remaining, the owners have to agree that the item is returned correctly. That means, okay, we have to check if that item is not broken or something. And this is what we understand from items. We're starting to think in items beginning from a cargo bike or something, maybe over some kind of trailer, like you want to own a car with 5 people buy a car, and then they're owning it together, and then they decide, okay, you want to have the car at the weekend, you can have it. And we imagine the use case that we are now presenting up to some tunnel drilling machines which cost up to 1 million euros a day or something. You know, I don't know if most of you come from Berlin. The last 5 years, this kind of thing was in use in Berlin, I guess, to drill that U5 metro. It's extremely expensive to buy it, and it's also very expensive to rent it if someone's needing that for a certain amount of time. So the technology we're using to enable that use case is called IOTA. IOTA, I will come to that in a minute, is a little bit different than the blockchain technology that you are used to know, maybe. It is a little bit related to blockchain, but it's definitely not a blockchain. We're using a distributed approach for storing transactions, and this is why we chose IOTA. We wanted to have no single platform or some single database that stores the data about the transactions for renting. We wanted that all the decisions that are made by the sharing group and the renters and the refunds and everything are documented forever. And we wanted that no party that is renting something should control the item's state alone, which means all the members of the party must control the item as a whole. They all have to agree if someone's using it. All information should be untemporable and undeletable. And all the values should move immediately. So this means if someone wants to rent something and says, okay, I'm ready to pay 1,000 euros or something, that value should move as fast as possible so you can use the item as fast as possible. If you never heard IOTA, and some of you did, obviously, because you raised your hands, I would like to introduce a little bit to what they are doing. It's a non-profit entity, some gemeinnützige Stiftung, under German law. It stores transactions, and this is what I showed you before, in a directed acyclic graph instead of linear hash blocks. So it's not a blockchain technology, it's a tangle technology. It's a little bit different. There are no miners in this kind of technology. Each transaction must verify 2 old ones instead. This means if you want to put some information in the tangle, I will show it you again here. If you want to put some information at the end of it, at the very end of it, which is actually there, over there somewhere, you have to find 2 old transactions and verify those on your own. This means you are the miner. Every one of us is a miner if you want to put something on it. The more users are adding transactions to this tangle, the faster that tangle on the network gets. This is amazing. If you know blockchain, a transaction can take forever. I mean, it depends on how much fee you want to pay to all the miners. There are no transaction fees in IOTA, and if you want to be that tangle fast, you have to put more transactions on it. So more people verify the old ones. This network is currently in beta mode, so we are using it and it's working quite fine. It's sometimes a bit slow, but you can use it for professional use cases, but no one's guaranteeing you that it's completely secure. This is what no one can tell you today, I guess, but we are pretty sure that it is. To keep the network running, people have to run so-called nodes voluntarily. This is something people ask me all the time. Why are you running one? You don't get anything for it. I said, yeah, because I want to have the use case working. This is why I'm running that IRI. It's not really expensive, but you have to do it. And many people have to run it, so you can use the whole network. And what's also very interesting is the IOTA Foundation is backed by large industry partners like Bosch, Volkswagen, or Fujitsu. I think that announcement has been taking place 2 weeks ago. So I don't want to get in all the concepts for you, and I mean, this should be more or less a basic tech talk, so I will just explain some basic phrases that will go with us through the talk. The first one is the so-called seed. The seed can be seen as some kind of password, which you have to take to take in your pocket, and it has to be secret. So you may not give it to anyone. The seed is quite close to the seed that you know from Bitcoin and blockchain. It actually defines how your wallet is working. What's different from blockchain is in IOTA you have so-called addresses. And an address is generated or based upon your seed. You create some index, and the addresses are derived from the indexes, and the index is counted up. So every time you want to transfer something, you have to create an address on the tangle, and that address is based on your seed. So today I create the first address, tomorrow the second address, and so on and so on. The transaction is actually taking place between addresses. That means a transaction could be withdraw money from one address and put it to another address. So transaction is just the granular part of it. It just says I'm taking something or I'm giving something. This is what you see at the bottom here. This is actually the definition of a bundle. A bundle is a collection of transactions. And it says if I want to give 800 euros to someone else and I have 1,000, this is what's actually happening. I'm telling the bundle, if everything is fine, you have an outgoing transaction that gives 800 people to the 800 IOTAs to the guy I want to give 800 IOTAs. Then I have to take 1,000 from my own balance, so I'm not having anything then. Then I have maybe some more transactions to store information, and then the remainder 200 IOTAs go back to some remainder address that I can give the bundle, and this is where I get the rest of the money from, 200 IOTA. Now, here's some code. This is code.talks, I guess. This is why we wanted to present you some very, very simple basic stuff that shows you how you can create a transaction on the tangle. The funny thing is you can do and you can execute this code on your own, given that you create that seed on your own. The funny thing is the seed is just a random number, so you can create it just on your own. You can just think of something. All these funny letters over there, you notice this is all the letters from the alphabet plus nines. This is so-called tries. I don't want to get into detail of this one. It's quite an interesting aspect of IOTA. So if you have a seed and you have an address, you can create the transfer and you can send the transfer to the tangle, given that you know some kind of node, some IRI. You see this at the top, it says new IOTA provider, something, IOTA node party or something. This is actually the address of a node that someone is running for free, for you, voluntarily, like I do. Not this one, but another one. So this is how you can put a transaction on the tangle. And this is how it looks like if it's confirmed. This is a completely different website. This is some website called, I don't know, IOTA search, I guess. You can give the address that you got out of the process over there, and then it will show you what happened there. And maybe if you think back of 2 slides ago, you see this is quite the same stuff that I put on that slide. It's actually showing you how everything looks like. You know, there are several addresses and hashes of the transactions, and you see 10 IOTA are going out of it. They should be put on the target address, and then this is the remainder that I get are 4,700 something IOTA. So, back to our initial use case. Now that we know what IOTA more or less is doing and how it's looking like, I can tell you how we are solving this renting problem. The renting problem, like people are owning some item, like a tunnel drill or a car or a bike or something. And what we are doing, we're utilizing so-called multi-signature wallets in IOTA to enable sharing groups. So multi-signature wallets are not unique to IOTA. They are also in Bitcoin or in other blockchain technology, but IOTA also got them, and they're created by so-called, by subsequently adding key digests of all users. That means you're creating some digest of a private key that is derived from your initial seed. Don't understand me wrong about the details, but you can read them later if you want. And the order of that sign process is really important. The good thing is, if let's say David and me and Peter are agreeing that we are owning this little piece of technology here, and we are signing in the order that of David, Stefan, and Peter, and someone wants to have it, we all have to agree on it in the ordering of David, Stefan, and Peter. This means only we three as a party can agree on what's happening with the money on our common wallet. So the result of a multi-signature process of the process that is creating that wallet is a so-called initial address, and we can put money on that address. Now, to withdraw money from that address, I mean, putting on money is quite obvious. You just tell, okay, send money to the address, then there's money on it. But to get money back from that address, we all have to agree again. Now, this is how a multi-signature wallet could look like in JSON. There's lots of text on it and lots of letters on it, and I don't want to get much into detail here, but you have to keep track of it. And the problem is there are no real good tools out there in the world which are making this simple. This is why we wrote this kind of tool. I actually planned to make a demo, but I now think that the demo is quite good, but I will do it at the end of the presentation. So just trust me, we can create multi-signature wallets using IOTA with code. So how is the rental process looking like? First, all the parties that agree that they are owning the item have to agree on their ownership. This means they are creating the so-called multi-signature wallet, what I just showed you. So 3 people say, yeah, I think we are owning a tunnel drill machine, so we trust each other, let's create that multi-signature wallet. The multi-signature wallet is now denoted as the little piggy bank over here, it's green. Second, someone of this group says, I think I need this item for some days. I need a tunnel drill machine for 1 year. Then the others say, oh, okay, I don't need it. I don't want to drill a tunnel next year. You can have it. What they are doing, the both remaining, or maybe the 1,000 remaining parties, I mean, we're talking tunnel drill machine here, they are building another multi-signature wallet, now denoted in piggy bank yellow, and say, please put a deposit in our piggy bank. So the 2 people at the left control the yellow piggy bank, and all the 3 of them control the green one. Remember this, they are multi-signature wallets. The one who wants to use the item is transferring the deposit onto the warranty wallet. This is how we're calling it, actually. We're calling it the warranty wallet because it's a warranty that even if he breaks the tunnel drill machine, we can buy a new one. Or maybe if he steals it or something. Some time later, let's say 1 year in terms of our tunnel drill machine, he says, I don't need the tunnel drill machine anymore. I think I drilled a tunnel, everything is fine. So please withdraw or subtract the usage fee from the deposit I gave you, and the remainder I want to have back on some new address. This is XOS9AH, whatever. So he says, please, I want to have it, I want to give it back to our common sharing group. And then the 2 remainders are giving, sorry. No, I have to read on my own. Okay, let's start the return then. They are giving him back what remains, and they are keeping, sorry, the usage fee in the common multi-signature wallet. Right. I did something wrong now. I'm sorry. So of course the remainder, what has not been used, goes back to the original requester, and everything else stays on the common multi-signature wallet. So what's now in the common multi-signature wallet that is for the sharing group can be used for example for maintenance. If something broke on the tunnel drill machine, or if we agree on buying some new of them, this money is still there to be used for maybe maintenance, maybe, I don't know. Nice to have it. So I wanted to have this Philosopher Raptor here for you. If smart people agree on a time transaction, Should we call this a smart contract then? This is what I'm thinking about for more than half a year already, when we first came up with that idea, because there are no smart contracts in IOTA. There are smart contracts in Ethereum. But I think we found some use case here which is not unrelated to something other people would call a smart contract, and this is why I would like to show that Velociraptor for you. So, without further ado, you might wonder, but how does the device or the item know that is used? And this is the topic of my good friend David Lobato. He will talk about the IoT part.
Okay, so yes, till now, Stefan has been showing the example where you keep this sharing group and where you have the trust of who has the item and how you eventually could get back some deposit to repair the object and all this stuff. But we haven't talked about how do you measure the usage on the object, or how do you get any sensory data about the status of the object. And that's why we bring the IoT matter to the topic. So basically, we need. It would be a pity that after all the effort we've done with building all these multi-signature wallets and stuff, we have to go and manually check the status of the item. So nowadays we have very nice technologies where we can measure the status of the object just by installing some sensors or by attaching some computer that is connected to the internet to the main computing unit of the track or the drilling machine or whatever. So the IoT technology allows us to track the usage of the object, most basic one. Detect also overuse. So let's say that we've agreed on using the object like for several hours, and the other one is not really following the conditions. So we can also detect that, or we can detect that the use is out of the agreed conditions. Or we can also log usage peaks for statistical usage or whatever you can imagine. Also, it could enable us pay-per-use scenarios where we are renting a device with a fixed price per renting, but also some sort of variable amount per usage, like per hour that you've been using the device, you will pay whatever. And the device can report back that it's been used in this exact moment. And also it could allow us to automatically unlock the item. Imagine that we have the item on storage, and for accessing the device, you need to give someone access to such storage. So you could also implement some sort of idea behind that. It's not by chance that we chose IOTA to work with on this concept, and it's because IOTA is being developed very closely to IoT, and the main goals is that this is easy to integrate with IoT, which is a very big trend in IT nowadays. And for that, they implemented a second layer on top of the IOTA protocol that is called mask authenticated messaging. And basically, this enables us to track the item usage just by publishing transactions, the same kind of transactions that you would do to transfer money, but in this case, transactions that have zero value, but have a message in there. And this gives you a very nice way to access the data, because you can trust the data, because if a transaction is being accepted in the tangle, you can trust that what is there is trustful to the origin, because it has all the properties of any other transaction. Will have a digest, and the data is signed, and you can verify that it came from whoever is saying that it produced the message. So IOTA mask authentication messaging opens an encrypted data stream on the tangle. So basically, you can produce these message transactions with zero value, because one of the main features of IOTA is the transactions are filled, so you can just produce as many transactions as you like. And this actually helps the network. This is what they say, because as more transactions are introduced into the tangle, faster it gets, because they actually need more transactions to validate the older transactions. So this is actually helping them. If you start publishing transactions onto the tangle. And it also, this layer is not also about, it's not only about the streaming data, but it also has some features as you can control who can subscribe to this stream. I won't get into the details because it's kind of, it's not very difficult to understand, but it gets a bit messy. But basically you have 3 levels of access. You can just publish your stream as a public data, or it can be private, so you have to tell someone where to look at, or you can even encrypt this data. And it also have a very nice feature that is the forward secrecy, that you can have a live stream of data, and you can give access to someone at this specific point in time, and he won't be able to see back in time. You have a stream of data, but it's ordered, and you can only go see from the point where you have access to. So basically, our IoT devices can stream sensor data into the tangle. Just not to confuse, this is not real-time telemetry. There's gonna be some lag, some delay on the transmission of this sensory data, and it's definitely not the best way to transmit sensor data if you have a huge amount of data, because the payloads that you are adding to these transactions are just huge. If you're just sending a small several bytes of sensor data, the payload that you're adding to this transaction is like in the order of kilobytes. So it's kind of, but it has some use cases, and in our concept, the use case is to be able to track this the sensory information from the object. What kind of devices we can use for this? In general, whatever device you can think about, because they provide several libraries to interact with the network, and they go from JavaScript to Pythons to C++, whatever, name it. And there's an active community behind it, and there's a lot of people developing new libraries. Here sorry. Here I've just brought several examples. Definitely, at the end, it will depend on your scenario, and you will have to choose the device. You will have to think about things. Do I need to power this device by batteries or not? Do I have a stable connection to the internet? It will depend. I mean, this is really really something that you need to focus on the specific problem. But here we have 3 nice devices that maybe some of you know. Is the Nordic Semi, the series of NRF5, which are like really low power devices. Very easy to work with. They have Bluetooth connectivity, or we have this Espressive from a Chinese manufacturer, ESP32, that give us Wi-Fi connectivity and Bluetooth, also very low power. It could also be powered by batteries, but this is a bit more power hungry than the other one. And also, and by the end, we have a full-blown computer. So with a Raspberry Pi, you can pretty much do whatever. This is not very good for low power, but I mean, it depends on your scenario. In our case, in the hackathon that Stefan was mentioning before, we were working with the RubyTag, which is based on, it has a Nordic Semi NRF51, and it incorporates several sensors like humidity, temperature, and acceleration. So you can do interesting things just with this, and it's also is battery powered. And with the standard firmware that they provide, they say that they can run for several years. So you can imagine that you can do interesting stuff with that. I brought some of them if someone wanna see them later. So in our scenario, the setup would look something like this. We have our track, and our track has some sort of sensor. It would be kind of, maybe there's better hardware for the huge track, but yeah, we are gonna put a RubyTag on top of it. And RubyTag does not have access to the internet, so it's just a Bluetooth, and we configure it as a Bluetooth beacon. And basically on the other side, we have, it would be also sitting on the track. We could have a phone. We actually made this running on the hackathon with an Android phone that has connectivity to the internet. And basically what happens is that the RubyTag is streaming as a beacon the sensor data that we are interested on. And the beacon detector application will just produce the message and will attach it to the tangle. As simple as that. I mean, they have this very nice library to work with mask authentication message, and it's really simple to attach these messages. And on the other side, we will have the sharing group that could that with the right address will be able to observe this sensory data, and with the nice property that they can trust the data that they are getting, because it's gone through the tangle. If the tangle accepted the transaction, is because it's a valid transaction, and then you can trust the data that is there. On the application side, you could also think about that anything. You can implement this on a Raspberry Pi or on a regular computer. It's just about it depends on your scenario. And in our case, we work with this Zephyr operating system that is really nice. I don't know if you've heard about it, but it's very simple thing to start with Bluetooth projects, and with this Ruby tag works quite well. And now I will pass to Stefan to wrap up.
Thank you, David, so much. So, who of you understood what David was just talking about? At least 2, 3, 4. Okay, some of you, very good. Lots of you, many people coming up. I find this stuff quite amazing because I have no clue about hardware, about IoT anyway. I like the IOTA idea because I want to put data on it. But I think David did a great job evaluating all this stuff. Thank you for this one. Even the Ruby tag. I mean, everyone was just keen, can I touch it, can I touch it? I remember it on the hackathon. So, to wrap up, what did we do here? We used IOTA multi-signature wallets to enable sharing groups and warranty wallets. You remember the little piggy banks, which can ensure that you are the owner of a device and that someone else is currently renting it. We created a trusted, distributed, and secure way to prove ownership. And we are communicating usage data via IOTA MAM, the masked authenticated messaging. So just in case you're wondering, have these guys actually done that, or are just talking about this? Yes, we've done that, but unfortunately we cannot show you a completely working application. We only implemented all the parts of it. We took lots of effort to do it on the hackathon, on our free time, and on the last 7 days, I guess. I will show you something in a minute. But it was really fun to see how everything plays together in the end. So what are the advantages of our approach of the renting business? The advantages are there's maximum transparency for all parties as long as you know all the keys. So since you have used that MAM part and you know the key, you can see where the container ship currently is, how the current status of the tunnel drill is, where your bike currently is, and who's using it and where it is if you want to enable this kind of scenario. The other good thing, of course, and we mentioned this 10 times already, the transactions are fee-less. That means if you want to rent a 1 million or a 1 billion worth of a tunnel drill, you can rent this one without paying anything to a bank which has to transfer the money or something. What's giving us hard parts, and there's one thing in it, it's called identity. And this is one of the worst things to do in blockchain technology. How do you identify in a decentralized network that you're talking to the right people? This is a yet unsolved problem. There are lots of people working towards it. We haven't solved it as well. I can show you how we did it, but there's some, it's rather simple. The other thing is, if you want to create that wallet, you have to share it so everyone has access, every one of the sharing groups has access to it, and they can use it to authorize all the transactions. So this means you have to store the wallet in a safe storage, because this wallet really contains money in the end, and you have to be able to transfer it in a secure way. And everyone, of course, has to keep their seats. If only one of the sharing group is losing its seat, the whole wallet is useless, because you will have to have the wallet to transfer money. I gave you some pointers, and how much time do we still have? I mean, maybe 5 minutes? Do you want to see some kind of a demo? Anyone? Yeah, some kind of demo. I love this. So the good thing is you can even open it on your own browser, and we took quite some time to learn React.js with it. It's rather simple. So, we are only presenting how to create that multi-signature structure here. So the good developers among you will say, what have they done? This is only JSON. But it was not that simple, I can tell you. So let's say we're sharing, what should we share? A container ship, a tunnel drill? What do you want to share? A container ship. Okay, Musin, the winner of the hackathon, one of the winners wants to share a container ship. A CSS container ship. This is one of the dumbest ideas. Sorry, a CSS container. What is a CSS container? You don't know. Okay, wait a second. But we can use a real Docker container. I don't know if you know Docker containers. I would like Docker container. Okay. I think to rent it, we should leave, let's say, 100,000 IOTAs. And to rent it a day, I mean, it should maybe come with 10,000 IOTAs, shouldn't it? I think so. Yeah, container ship, obviously. And I myself, my name is Stefan. This is what we call identity. I'm sorry, this is so primitive. Now, what you see here is now the existing structure of the beginning of a multi-signature wallet. Currently, we only know that my name is Stefan and, some metadata about the object that we want to own. Now, let's say I have to give my seed digest to it. So I'm creating a new seed here, which is just basically creating a random number. Or creating 81 random numbers, for that matter. And I created a random seed for me. This is like a real wallet. If I don't go on now, I could use this to get money, to create addresses, to receive and to transfer money. But what I'm doing now, I'm adding the digest of this seed to our now shared multi-signature wallet. Here it is. And now you notice I cannot go on here on this. This has a reason. Because this seed is something I have to put down, put in my locker, give my bank account or my grandmother or someone who is safe or I trust. This may never get lost. If this gets lost, the whole wallet is lost for all of us. Trade-off. I mean, we should put it there somewhere. So let's say David is also on the container ship. Sure. So I'm copying now the text. Remember, this is decentralized. There's no server, besides the web server delivering that application. There's no database or nothing. And David is known to use Firefox as his preferred browser, I guess. And he goes to that same application. Say, okay, Stefan just sent me an email with the beginning of a multi-signature wallet. He pastes what I just have copied and adds himself with another secret seed to that multi-signature wallet. This is not the seed. This is the digest of the seed. Okay, this is so the first from the first private key that could derive to a real address. Quite hard to explain. So we could play this game another time, maybe with Peter. If you don't mind, Peter, everything's fine. Yeah, okay. Demo. Peter loves demos. So Peter's also on that page. He pastes what David has sent him. His name is obviously Peter. He adds himself and he says, yeah, Stefan, David, and me, we have this container ship. These are the conditions that will apply on if that one is rented, then let's finalize this one. And now this is the real magic. Magic, I mean. There's an address in the end. Can you see this? Oh, a little bit, I hope. And this address is a valid IOTA address. And the balance of that address is 0. And with 0, I mean, you can ask anyone. You can even ask the official tangle org. This is some kind of website. I don't know who's even powering this. You can paste that address here, and it's not there. Because we never attached it. Oh, I'm sorry. Of course, this is not... that's a thinking problem. But we prepared something for you so you can trust that this is really working. Here is one. And please, these are the real seeds. So I think this talk is recorded. You can use them. There are 70 IOTAs on it. I think they're currently worth 0.00005 euros. So if you want, you can steal me. I don't care. The sample was a seaside cottage that we wanted to share. I pasted just in here. And now there's an address written here, and it has a current balance of 10. And this is what I meant. You can, if this one is attached to the Tangle once, or someone has sent money to it, you could ask anyone and say, how much money is on that address? And it says, oh, there are 10 on it, but there are 89 IOTA pending. This is what I sent when I left office today, and they're still not arrived. And now you maybe notice why we're not showing a real demo to you, because these 89 IOTA have not arrived for more than 5 hours now. So IOTA is working, but it's not really working stable. This is why we cannot demo it in a real way. But we tried our very best. So without further ado, let's switch back to my little presentation here. Since this one is shared, I'll have put some pointers for you over there. We use React.js, obviously, and Netlify to host this stuff. It was amazingly simple. We use GitLab for the code hosting. That was everything. You can have a look at our code at the repo. And if you want to read more about that MAA messaging or the multi-signature client or the ideas of that client, you can go to these links. They're pretty good. So that's all, folks. Ask us anything. Thank you. There's one. You have a screen. IOTA per se is actually rather fast if you find the right IRI, which has lots of neighbors which are fast. It depends on which part of the tangle you are. And you can make transactions really fast if you reattach it to different IRIs. So they say, oh, there are people giving us the same transaction, and this is so-called promoting. You give it to different IRIs so they know about the truth that you want to have in there. And not too many people are doing it. If more people would use it, it would be much faster, I guess. Answer that one. So first question is, wasn't it supposed that a sharing group is renting to someone else? And then maybe I'm sorry that you got it wrong in this place. It's about we as 4 people afford some quite expensive item, and we agree on who may use it of us. You know, everyone paid something for it, and I say, okay, on weekends Peter can have my car, and on Tuesdays maybe Musin may have my car. You know, this is how it's supposed to work. You cannot give it to someone else. When you use this scheme, if you want to rent to an arbitrary person, you have to invite it to some kind of new multi-signature wallet, which would be a major overhead, I guess. Next question from you. What happens when exchange rates are so bad that the value of the deposit that you gave is only worth a tenth after 1 year? Sorry, this can happen. Then you should not rent it for 1 year, or you should, give it back underway and create a new contract. This is why this is not a really smart contract. It's just a dumb contract, but yeah. I'm sorry, there's no way to get around this. This is actually a major issue of all cryptocurrencies, obviously. I mean, if you pay 1,000 euros today and you get 500 tomorrow, we have a problem, but Germans know that, maybe from the past. Anyone else with a question? You have one. Very good question, actually. So what is happening when the 2 remainder of the sharing group, the warranty group, actually wants to cheat and say, you got the car, but we don't want to have it back. You can keep it, but we keep the deposit now. You have a good answer?
Yeah, I mean, in the scenario we show is pretty simple, right? But imagine that you have a bigger group, like imagine 10 people, and you in this case we've just enabled a multi-signature wallet where everybody has to agree. But it's possible also to enable multi-sig wallets where only a group of people has to agree, like M to M. Like you have 10 and maybe just 3 of them can agree. Any 3 of the group. So this is also possible in multi-signature wallets. And this could maybe solve the dispute, because instead of having just everybody agreeing on such a decision, you could have a consensus among the owners. Well, I mean, what we are thinking here is a kind of model where there's some trust involved, and definitely, definitely the guys with the deposit could control the deposit. It's about the trust between the group, right?
You still lose the containership, you know? If someone's cheating, you're losing the containership. I mean, and either you go with the containership or I go with the deposit. I think this is the idea of the deposit, isn't it? Is it? I mean, and the M2N idea is also quite interesting because, let's say we have a sharing group of 6 people and either four may agree that they are doing something with it. This is possible in IOTA, and in Bitcoin is actually also possible with the Bitcoin wallets. But then there's a big trade-off in IOTA. You have to share your private keys among each other, so everyone may generate digests. So I think this is maybe a little bit of a response to that question. If you say 3 people may agree instead of all of them, or 6 or something, then even if someone wants to do something, the others can decide against it. This is sometimes also possible. Sorry. Anyone else? If you want? Who wants to run an IRI on his own? You want? I don't know. Someone? You can run it on Kubernetes, on AWS, whatever you want. Not that hard. Okay. So the company's name actually was Turbine Kreuzberg. I think you couldn't miss it in the end, but I will just show you that slide, of course, again, so we can have a goodbye slide here. We are actually an e-commerce agency from, you will guess it, Kreuzberg, and we are also having subsidiaries in Portugal, Faro, in Stuttgart, and in Leipzig. More to come. We're currently 80 employees. We're mostly doing PHP, but we're doing also quite some new and advanced stuff, also JavaScript. So thank you for attending. If anyone has a question, you will find the slides obviously online. And my name is Stefan Adolf. You find us on Twitter at Stadolf and David Lobato at LinkedIn. The links are also in the slides. Thank you so much.